Picture the year 1886. The air in New York Harbor is incredibly damp, aggressively salty, and completely filled with invisible, metal-eating sea crystals. When the Statue of Liberty was first unpacked, she possessed a shimmering orange-brown finish, looking exactly like a brand-new penny. Moving the monument required tracking 214 wooden crates across the Atlantic, where workers spent months hammering thousands of rivets to fuse 350 copper parts onto the frame. America had successfully assembled the largest metal sculpture on Earth. Then, they placed it right in the middle of a brutal, salt-heavy marine environment. That placement was incredibly dangerous because of how the statue is actually built. The pure copper outer shell is completely hollow, and the metal itself is an incredibly fragile 2.4 millimeters thick. If you take two modern pennies out of your pocket and stack them together, that is the entire thickness of her metallic skin. To prevent the delicate shell from snapping, this cross-section reveals Gustave Eiffel's ingenious design. He installed a massive, flexible iron pylon down her center. The outer copper connects using specialized sliding clips, allowing the metal to sway several inches during storms without breaking. But while Eiffel's internal skeleton saved her structure from the wind, her paper-thin outer layer was left completely exposed to the chemical attack of the sea air. That exposure triggered oxidation. When oxygen atoms in the harbor breeze touch the pure copper atoms, they lock together, creating a new substance. Normally, this takes decades, but Atlantic salt acts as a chemical catalyst, aggressively turbo-boosting the reaction and accelerating the color shift. By the year 1900, this accelerated chemistry left the monument looking heavily mottled, covered in a patchy mix of dull brown and light dusty green. Within another 6 years, the reaction finished, permanently covering the entire monument in a solid coat of seafoam green. This teal-green coating signifies a rapid, aggressive chemical collision between the metal and its environment, occurring much faster than most copper structures built further inland. When iron undergoes a similar reaction, it produces rust, a flaky, weak substance that slowly eats the metal away. Copper, however, behaves very differently. The new green layer, known as a patina, is packed with complex minerals like barshantite. Instead of flaking off, it hardens into a tight, permanent glass-like shield. Once it forms, it completely blocks the outside oxygen from ever reaching the remaining copper underneath. There is, however, one very visible exception to this chemical rule, standing right at the top of the monument: the flame of the torch. During a massive restoration in the 1980s, engineers replaced the old flame and coated the new one entirely in 24-karat gold leaf. Because gold is a highly stable, noble metal, it chemically refuses to oxidize, meaning it will never turn green. This contrast highlights a chemical reality. The green patina is a self-grown suit of armor that keeps a fragile shell from disintegrating into the harbor. At first, almost no one understood the science behind this protection. In 1906, the United States Army actually believed the green layer was a form of corrosive rot, and they officially proposed painting the entire statue brown to cover it up. That idea faced immediate, intense backlash. Engineers and an outraged public successfully fought to block the paint job, realizing that covering the metal would destroy its natural protective layer. More importantly, they understood the original vision. The statue's French creator, Frédéric-Auguste Bartholdi, fully expected and actively wanted his sculpture to turn green. As a student of history, he had closely observed the weathered copper roofs of ancient European cathedrals. He specifically chose copper because he knew the harbor air would eventually weather the metal, giving his monument an ancient, timeless aesthetic. Without that public intervention, human panic would have completely destroyed a natural masterpiece that was executing its chemical design flawlessly. By the time of her centennial in 1986, preservationists knew better. When they encased her in massive scaffolding to replace Eiffel's rusted internal skeleton, the workers took extreme care to avoid scratching her outer green armor. They used specialized dry ice blasting to safely strip the interior without harming the copper. And today, high-tech sensors actively monitor the patina to ensure modern pollution doesn't degrade its chemical structure. Scientists now believe she has successfully reached her final, stable form. Barring a major environmental shift, she will hold on to this iconic teal-green coloring for millennia. The Green Queen stands as a monument to endurance, demonstrating that surviving a harsh environment generates the armor needed to make a symbol permanent.